Okay, question number 19. The graph shows the variation of the displacement of particles. So if you haven't read the question, please pause the video and go and read the question. Now, whenever you're doing a question like this, where they have given the wave and they're asking you to answer regarding the situation of the wave after some time, you need to understand that the entire wave pattern is shifting towards the right. So if we are to represent it, so right now the wave is like this. Right now the wave is let's say what's the yeah so alright, after sometimes what would happen is, if the wave is shifting in this direction, after sometimes, now let's say it's not an entire wave but it is just one wave pulse. Okay, let's say that it is only one wave pulse which is traveling. In that case, after some time what would happen is this entire pattern would have moved to the right, because the wave is traveling to the right. So the entire pattern would have moved to the right. See, this point has moved to this, which means that if you compared a point which means if you want to predict the future of this point here, the point corresponding to this, which is right now here, let's call this point A. So the point A is right now here. If you want to predict its future, given that the wave is moving to the right, then after some times this A will experience the same as the particle, say B here. After some times the particle A would go through the same experience as particle B. But the issue is okay, it's just don't consider this, because after some time both B and A are at the same B also at the same displacement. So let's take this scenario. Okay, now let's again consider the particle A. So right now the particle A is at its lowest bottom. After some times when the wave shifts, the particle A should have the same experience as particle B. So right now particle A is here. Okay, this is the original position, the equilibrium point of particle A, but right now it is here. So after some times when the wave shifts, the particle A will have the same experience as particle B. It is like that particle B is like the future self of or particle B is like the future self of particle A. So whatever the experience of particle B, it will happen to particle A as well, but after a certain time delay. So right now the particle B is sitting in its equilibrium point in his house, in his hole, but right, A is like far away from the equilibrium point at its extreme. After some time, A should have the same experience as B. Think like this. Right now, okay, I am at my house. Okay, right now I am at my house. Now tomorrow when they lift the curfew at, so this is 23rd March, 6:28 a.m. So tomorrow when they lift the curfew, that is 24th March around 9 a.m., I am going to be at the food city, right? Right now the house is my position, my equilibrium point is my house. Sorry, right now I am here, but tomorrow I would be here, right? So that is like comparing. So after that certain time, now if you consider the Gajantan who is in the future, he is already there in the food city. The future Gajan is already there in the food city. And the present Gajan, me, I am here sitting recording your lesson. But what I know for sure is I am also going to have the same experience as the future Gajan in approximately about 26 hours of time, right? So the same is the case with the waves. All the particles in a wave are going to go through the same experience. The difference is a question of time. So the particle A, which is right now, it's kind of not okay. The same case, if you consider particle B, so and particle C. Now particle B is like the present one, and particle C is at its extreme. After some times, particle B will have the same experience as particle C, which means it would go to the top extreme. It would go to food city. We are talking about time on the x-axis. Okay, so when the wave is traveling towards the right, what you have to understand is that the entire pattern shifts to the right. If you have understood that, then the remaining is easy. If after some times the particle should be at if after some times the particle B should be at C, then the particle B should start moving upward, right? If after some times the particle A, which is right now at its equilibrium position, if after some times the particle A, which is right now at its negative extreme, should come back to the equilibrium position, then it should also start moving upward. But if you consider particle C and particle D, now after some time the particle C should come back to its equilibrium position, the same experience as particle D, which means it should start moving downward, right? So that is the concept of this question. That is the concept of that one of the structure questions where you asked to draw the shape of the wave on a rope after some time, after a quarter of a period. So the concept is same. This MCQ is not different from that structure. If you have understood that structure, then you have understood this MCQ. So now considering that, now particle D should have the same experience as particle C after some times. That means it should come downward, right? It should come downward. At the same time, particle C will have the same experience as particle B. That means particle C should also come downward. Particle B will have the same experience as particle A. That means it should start traveling upward. Particle A will have the same experience as this region of the wave, which means it should start moving upward. The question asks you to find fastest upward. So the question is asking you to find the fastest so the question is asking you to find the fastest upward one. So obviously the answers C and D are traveling downwards, so they can't be the answers, which leaves you with A and B. So so far we've been talking about in terms of direction only. So as far as considering the direction, we can strike off C and D. Then considering the speed, now particle B, it is at its extreme. That means its speed is 0. That's why it is the extreme. It is like a ball thrown upward. At its highest point, its speed should become 0. Then only it will be the highest point. If it is possible to go even a bit beyond, if even a little hope is available, then it will not be the highest point, it will not be the extreme. Extreme means you are done, you are saying enough is enough, this is the maximum. So at point B the speed should be 0, then only it can come back. And when it comes back, all the energy, potential energy, now this is like a tension, so there is also that potential energy due to the tension of the medium. So all that will become the kinetic, and obviously it will travel the fastest through the equilibrium point. So that takes off the answer B as well, and leaving you with the answer A. When I look at your responses, it's quite interesting because the most common wrong response was answer C compared to answer A. So that simply shows that you have a clarity about the idea of speed. You know that speed is 0 in the extremes, and speed is the fastest in the equilibrium point. That's why all the answers I have received are either A or C. But almost equally half has chosen A and the others have chosen C, because you still don't have a familiarity with the idea of the wave shifting. So please do this, and please go and look at that structure again.